In this next section, we're going to get into talking more specifically about angles and the relationships that some angle pairs can have with each other. So, to kind of get us started, we're going to be going over some key terms, some vocab here, some words that you're going to be seeing a lot as you get going in this section. And we're talking about the different kinds of angles and angle pairs, and specifically what kind of connection or relationships that these angle pairs would have with each other. So to get started, the first thing I want to talk about is something called adjacent angles. And so if you think about the word adjacent, adjacent means next to or things that are very close to each other. So if I'm standing here and I said I'm adjacent to this desk, that would mean that me and the desk are side by side or very near each other, next to each other. So when we think about that with angles, we're talking about like two angles or maybe even a couple of angles in a picture that would all be by each other. If angles are adjacent, they have to do a couple of things. One of those is that they have to share a vertex and they have to share a side. Okay, so I'm going to go ahead and write that down here first. Adjacent angles would be two angles that share a vertex and a side. Now, we haven't talked a ton about angles yet, but we have seen them a little bit, especially when we were back in the very first unit. We talked about what an angle is and kind of how to name an angle. And I went over like the different parts of an angle, specifically what are the sides, what are the vertex, like how do you use points on the angle to name it. So we should know what a vertex is. And remember, that's the point where the angle is actually formed. And then the sides would be those two rays that kind of go off in a direction and are going to make the angle actually look the way it does. So I'm going to give you a couple of an example and a non-example here. So an example of adjacent angles would look like this. I'm going to number this angle 1 and this one 2. And so those two angles would be adjacent with each other because they share this point right here. That would be your vertex point. And they share this side that goes right between the two of them. So 1 and 2 would be considered adjacent to each other. They have to have those two things in common. They have to have a common vertex and they have to have that side that's kind of separating them, because then you can kind of see 1 and 2 would be next to each other in the picture. If I had that exact same picture, but this time I put 1 here and I put 2 on that side, those would no longer be considered adjacent. They're still really close to each other and they still share a vertex, but they don't share a side anymore because 1 would have these two sides that I went over there in red, and 2 would have these two sides. Okay, and you can see when I trace those, I didn't overlap my tracing at all. Angle 1 is kind of now outlined in that red, and 2 is in that brown color. They don't share a side, they only share the vertex. So those would no longer be considered adjacent anymore. Now, sometimes when we have adjacent angles, they might be put together in a very specific way that allows us to see, oh, those two angles are going to do something as far as with their measurements. They're going to add up to something or they're going to equal something. Okay, so now we're going to kind of get into some really specific types of adjacent angles. The first one is called complementary. And maybe you've talked about complementary before. When you guys were talking with me at the very beginning of the year about angles, you talked about things like acute angles, obtuse angles, straight angles, that kind of stuff. So you have seen these types of angles before, maybe, and you've talked about this idea of complementary. But what complementary means is that you would have two angles that add up to 90 degrees. So anytime we have angles in a picture, and they don't necessarily have to be adjacent to each other, but they could be. We need to be able to look at their measurements, like how much do they actually equal? And then if I were to put them together, what do they become? Like when I start to add those measurements together. So I'm going to draw a couple of examples. The first one, I am going to use what we just talked about, the adjacent angles. And we've seen something like this in pictures before, but you might have angles that look like this. Okay, I'm going to call them 1 and 2. But if these were complementary, there should be a little red box there in the corner. That's just telling you those two angles together are going to be 90 degrees. Like I said, though, they don't have to be adjacent. Like in that case, 1 and 2 share a vertex, they share sides, so they would still fall into our adjacent angles category. However, they don't have to do that. We could have pictures where angles are kind of separated, or they may be farther apart in a picture from each other. But if we know what their measurements are and we can still add them and get 90 degrees, they would still be considered complementary. So, for example, if I had angle A, let's just call this one, and they told me that this was 40 degrees. And then they gave me another angle. We'll call this one angle B. And they said that this one was 50 degrees. Those two would still be complementary because 50 plus 40 is 90 degrees. So you're going to have times where the angles are next to each other. Sometimes they're going to be separated. But as long as the two measurements add up to each other, they're still going to be considered complementary. So some examples that would not work for complementary would be if we had a picture that looked like this. Again, maybe they're going to call this one 1 and they're going to call this one 2. But if I look at that, that doesn't look like a 90-degree angle anymore. I don't think there would be that red square in the corner because it looks like it goes a little bit over 90 degrees. So that would not be considered complementary. Another example that would maybe not work for this is if I had something that maybe had that red box in it. So let's say that there is a 90-degree angle here, but if I had like a bunch of angles that made that up, these wouldn't really be considered complementary anymore because complementary, remember the definition was 2 angles that add up to 90. This has more than that. This has 3 in the picture. So would they still add up to 90? Yes, but we probably wouldn't call them complementary anymore because we have more than 2. And we're kind of stuck at that 2 angles limit when we're talking about complementary. Okay, so directly connected to that is this next vocab word, which is called supplementary. And supplementary angles are going to be, again, 2 angles, so no more than 2, that add to 180 degrees. So a little more than that 90 that we just talked about with complementary. Now we're upping it to 180 degrees. And just like we saw on complementary, these angles could be adjacent or they could be separated. So an example would be if they were adjacent, you would see something that looks like this. And so 1 and 2 here would be considered supplementary. If you think about what that looks like across the bottom, it looks like a line. All lines have 180 degrees in them. If you were to go from one point in a line and kind of imagine like an angle being drawn up above, almost like making like a rainbow shape and going to another point on the other side of the line, that from the distance between those 2 points is going to be 180 degrees. So kind of what I mean is like from here to here would be 180 degrees. Okay. Sometimes they'll call that a straight angle because it is a straight line. And we kind of talked about those lines at the beginning of the year as well and what they look like. But anytime you see that, they would be adjacent like this. They're going to add up to 180. Again, they don't have to be adjacent. They don't have to be connected. So just like we saw earlier, we could have 2 separate angles. They could say that this one's 120 and they could say this one's 60. Oh, I think I drew that angle wrong. Let me fix that. too far. Should go like that. That's a little bit more accurate. So that would be 120 plus 60 still equals 180. And that would still give me those supplementary angles. Okay, and then just like we had non-examples for complementary, a non-example for a supplementary would be maybe something that looks like this. It's getting really close to being 180, but it doesn't make that true straight line, so it's not going to work. And again, if I had several angles that were side by side by side, so I could even draw in like more arrows here if I had a straight line. Just like with complementary, you only need 2 in order to make it supplementary. If you have 3 or 4 angles being formed, yes, they can still add up to 180, but they would no longer be considered supplementary. Now, this example that I drew over here, this one actually has a very specific name, and that's the one that we're going to talk about next. It's called a linear pair. Okay, and what a linear pair is it's 2 adjacent angles that add to 180 degrees. So what I showed you earlier with the example where we had a straight line and we had one like extra ray coming off, these 2 angles, if I call them again 1 and 2, those would be a linear pair. So a little more specific of a name, just like we said before with supplementary, they could be together like this or they could have been separate. We're only talking now about the case where they would be next to each other. So they have to be like in the same picture. They can't be 2 separate angles. And they still have to share that vertex and that side in order to be considered adjacent. But when they are forced to be together and they make that straight line, we call it a linear pair. So it's just being a little bit more specific with that angle type. If I had a picture that looked similar, and we were talking about these angles 1 and 2, that would not work for a linear pair because those 2 would not equal 180. We're also missing that third angle. Now, if I called this one 3, angles 1, 2, and 3 would all make up that line and would still add to 180, but I wouldn't call it a linear pair because, again, a linear pair means 2 angles, not 3 or 4 or more, and same with supplementary. Supplementary definition said 2 angles, and so we're being a little bit specific with those names. All right, one more kind of angle pair name we're going to talk about today is something called vertical angles. And vertical angles are 2 angles formed by intersecting lines. And a little note I want you to put right here, maybe put like a little star by this. These are going to be congruent. And what does congruent mean again? Means that they're going to be equal to each other, okay? So when we see a picture like this one, where we have 2 lines that kind of cross and make like an X, all right? There's going to be vertical angles in here that start to show up. So I'm going to number these 1, 2, 3, and 4. Okay, and what I would know, just if I was presented with a picture like this, I don't need to know how much an angle is. I don't need to know really anything number-wise here. I could just recognize that those angles that are like directly across from each other in the picture are going to be equal. So 1 and 3, just going to kind of draw a line between them. They're directly across from each other in this picture. They are always going to be congruent. So I'm just going to write down here, angle 1 would be congruent to angle 3. And so the other angle pair that does that would be 2 and 4. So angle 2 would be congruent to angle 4. Okay, a non-example of vertical angles would be something like that. 1 and 2 are still somewhat across from each other, but if you look at those, 1 appears much smaller than 2. So those would no longer be considered vertical because they're not congruent to each other anymore. Okay, now this last thing here says we have a follow-up question. What other angle pair is also present in number 5? And then they're saying, like, list all the pairs that you see of this type. So if you look at number 5 again, does it resemble anything that we talked about earlier? Like if you look at angles 1 and 2, they're side by side, what other angle pair would they make? Yeah, they look like those linear pairs that we talked about. Okay, so there's also linear pairs that are showing up in that picture that I drew for number 5. I'm talking about this picture here. Okay, now I already kind of said like 1 and 2 would be a linear pair, but what other linear pairs do you see then? Yes, 2 and 3. What else? 3 and 4. Is there one more? Yeah, 1 and 4. Good. So hopefully you're kind of being able to look at a picture now and you can see like there's a lot of different types of angle pairs that could possibly show up. We're not limited to just like one type, but in that one picture, there's vertical angles happening and there's linear pairs happening. Okay. So we're going to start getting into solving some problems now. And we're actually going to be working with measurements at this point. So we might be just having to find the measurement of an angle, or we might need to solve for the value of x and then maybe still possibly find the measurement of an angle. It just kind of depends on what the question is asking for. But we're going to want to come back and look at these vocab words that we've talked about so far and kind of pinpoint first what kind of angle pair are we dealing with here and looking at, and then how do we use that information we talked about to set this up. Okay, so let's get into these problems here. So number 7, let's start here. What angle pair do you see happening in this picture? Okay, hopefully you're thinking like they're across from each other. They're not adjacent because they don't share a side. They do share a vertex, but they're not adjacent angles. So that means that they're probably not complementary or supplementary per se, because we can't use those because they don't kind of fall into that category from up above. But they are across from each other. And we talked about an angle pair that does that, which would be your vertical angles. Okay, so these would be considered vertical angles. They're directly across each other in the picture here. And what did we say? Vertical angles are always what? Yeah, they're always congruent, which means what again? They're equal. Okay, so when I'm thinking about how to set this up, and I thought, okay, I know that they're equal to each other, I probably just need to stick an equal sign in between them. So I'm going to write this out. I'm going to say 6x plus 5 equals 89. Because I don't know what x is, but I know that if I had the value of x and I plugged it in, that they should equal each other. Okay, so we're just going to set this up, and now we're going to solve for x. So I'm going to start by subtracting 5. Okay, I'm going to bring down my 6x. 89 minus 5 would be 84. And then we do what? We divide by 6, and what do we get for x? And it's okay to use a calculator here. Good, you get 14. Now, a follow-up question here, and this would be an excellent thing to do like on a quiz or a test day if you have extra time. Okay, if you have time and you want to go back and check your answers, how could we make sure that we did this right? I should be able to take this 14 and plug it in over here. I should be able to take 6 times 14 and add 5. And what should it equal? Should equal 89. And it does. Okay, if I take 6 times 14 and I add 5, I do get 89. But if you were taking a quiz or a test in the future and you have a little bit of extra time, it does not hurt at all to take a couple of minutes to go through, plug your value back in for x, and make sure that it makes sense with the relationship that you used. So since you know that those were vertical angles, you should know then that their measurements should be the same. So if I had plugged in X and I got something like 72 degrees, one, I would maybe check like, did I plug it in correctly or did I type something in wrong on my calculator? But if I'm still getting that and they're not equal and I'm like, that doesn't seem right because I know that they're vertical, then I need to go back and check to see how I solved it. So doing something like that could potentially save you from making mistakes, like if you missed it, because sometimes when we're doing these problems, like students get really comfortable with it and then they start to rush through things and then they don't go back to check. But if you go back and kind of check things from time to time, it can really save you a couple points here or there. So it's worth it if you have that time to spare. Okay, let's go ahead and go over here to 8 and do this one. Okay, what angle pair do we see on this one? They're not vertical this time, okay? Because this time, if you look, there's a common vertex and there's a common side here. That side is shared between the two. Okay, so these would be adjacent. If we also kind of just focus on like the bottom half, trying to go over it here in red for you, what does that make? Makes a line, okay? And anytime we see a line, I always think linear pair because linear has the word line in it. So I'm thinking, okay, those two angles, they make a line. All right, so what does a linear pair do? What did we say up above? They add up to 180. Good, they're supplementary, okay? Because they're adjacent, they're next to each other, they're going to add up to 180. So if I want to set this up as an equation, I'm going to take these two angles. Now I have expressions for both of them. Neither one of them are giving me a direct measurement here. So I'm going to take 3x plus 2. And if those two should add together, I need to put a plus sign in between them and set it equal to 180 because that's what a linear pair does. Good. Okay. Now let's start combining like terms. So on the left-hand side, I see a 3x and an x, so that's going to become 4x. And then I have a 2 and I have a 14. So those together would be 16 equals 180. Go ahead and take a minute and finish solving that for x. Okay, you should have subtracted your 16. So you've got 4x equals 164 divided by 4. And you should have gotten x equals 41. Good. And then again, how could you check this one? You should be able to plug them back in and see if they add up to 180, okay? So if I think about that, 41 plus 14 for the right-hand side there would be 60 or 55. Okay, and then over here, if I took 3 times 41 and then I added 2, that would be 125. And if I add 125 plus 55, I get 180. So it checks out. It follows the rules of the angle pair I was trying to use there. So I feel pretty comfortable with knowing that I did that one correctly. Okay, why don't you guys take a look at number 9 and see what you can do with it. Okay, if I'm looking at this one, I notice that little red box right away. And what does that tell us about the picture? It's 90 degrees there, okay? So these two angles, the 2x and the 28, they're kind of in that spot that's making that red box. So those two together should add up to 90 degrees. So I'm going to go ahead and set this up by adding 2x plus 28. And we're going to set that equal to 90. And then I would have subtracted 28. I bring down my 2x. It's now equal to 62. I divide by 2, and I get 31. So that's my x. And then again, if any of you went back in and checked it, if you took 2 times 31, this becomes 62 degrees. And 62 plus 28 should add up to 90. So it makes sense. All right, we've got one more here. Now this one, they're not putting anything in the picture. They're giving you all the information up above in the description. And so what we're going to have to do here is probably fill in our picture first. This is really similar to those segment problems that we did yesterday, where you had to draw a picture and like actually label the parts of the segment with the information that was given. So we have to do that for this as well. So I'm going to start out by labeling what I know, and I'm just going to kind of do that by reading through the problem. So measure of angle IBA. So just follow those letters, I to the vertex B up to A. That's 10x plus 10. So that's this part right here, 10x plus 10. So just squeeze it in there if you can. And then CBI, that's the other side of the angle down here, is 7x minus 2. And then it says that angle CBA, which would be this entire thing here, is 127 degrees. They want us to find the measurement of angle IBA. So we're going to have to solve for x first and then use that to plug in for that specified angle. So how do you guys think we need to set this up? If you think about what we did with those segment problems yesterday, we had the little pieces of the segments and we would add them together to get the whole thing. And so if we had all those pieces, you'd add up all the little pieces, you'd put plus signs in between them, and then you set it equal to the entire thing, whatever it was, a number or an expression. And we're going to have to do the same thing here. So we're going to add the pieces, which would be the 7x minus 2 and the 10x plus 10. We're going to add those. And we're going to set it equal to the whole thing, 127. And then we're just going to do combining stuff, like use our algebra skills again. Okay, so we've got 7x and 10x together would be a 17x. A negative 2 and a 10 would be 8. Equals that 127. I'm going to subtract 8. So I have 17x equals 119. Divide by 17. What'd you guys get for your x here? Good, 7. Are we done though? No, remember it said up here to find the measure of angle IBA. So we're not quite finished. I need to take this answer that I just got here, 7, and I need to plug it into this piece, the 10x plus 10. So I'm going to do 10 times the 7 now, plus 10. And so 10 times 7 would be 70, plus 10 would be 80. Again, if you wanted to check your work, you could take that 7, plug it into the other side. So 7 times 7 would be 49, minus 2 would give me 47 here. If I add 47 and 80, I get 127. So again, that just kind of reassures that I set this up right and I got the correct answer. Okay. Do you have any questions on those angle pairs here today?